Welcome to the November 2025. This is the Edexcel IGCSE paper 1H, November 25. Question number 1. We got a group frequency table. We asked to estimate the mean. So standard procedure for a group frequency table, I'm going to multiply the mid-interval values, that's the midpoint of each of the ranges, by its corresponding frequency. So 2.5 times 8, 5.7 times 7, and so on, all the way to the end. Sum them, divide by the total frequency, that's 30, and we get a mean of 11 kilometers for question 1. Question 2, rounding each number to one significant figure, 2 squared times 60 over root 9, which is the same as 240 over 3, which is 80. So 80 for question 2. Question 3, usual apologies for the appalling standard of my diagram. I don't have a pair of compasses I can use on the screen, but your graph should look something like that with those construction lines and a line that bisects the angle. Question number 4, we can deduce that E must be 2 because the range is 15. We know the median is 8.5, so that tells us that G must be 10 because 8.5 is halfway between 7 and 10. And then if we sum them, we know we're going to get 54 because it's going to be 9 lots of the 6 digits out there. And then we can work out that F is 6, so 2, 6, and 10. For question 4. For question 5, show that question, so make sure you show all the workings. I've turned them into top-heavy fractions, found a common denominator of 21. Add the numerators, we get 113 over 21. And lastly, write it as a mixed number, that's 5 and 8 over 21, which is what the question wanted. Question number 6. So they're sharing $275 in the ratio of 2 to 3. So I'll divide the 275 by the 5 parts that that makes in total. It means that each part is worth 55. The person getting 2 parts will therefore get 110. The person getting 3 parts will get 165. Now, 3/11 is given to charity, so 3/11 of 110 is 30. That goes to charity. 0.32, lots of the 165 goes to charity. So times 0.32 by 165, we get 52.8. Sum together the 30 and the 52.8 means a total of $82.80 goes to charity. The lower bound is 474.5, and for part B, the upper bound is 125. For question 8, playing about with the indice rules, on the numerator, add the powers, -2 plus 9 is 7, and then to divide, we can subtract the powers, so it's 8 to the -3, n is -3. Question number 9. We've had something increase by 12%, so to reverse that, we'll divide by 1.12, comes out as 125. Question 10, anything to the power of 0 except 0 is 1, so the answer is 1. For part B, subtract 1 from both sides, subtract 5y from both sides, divide both sides by 2, we get y is greater than 9.5. Part C, full factorization, we're going to get 5w squared x squared outside the brackets, and then 3x cubed plus 5w inside the brackets. And for part D, 36 over 12 is 3, and then subtract the powers, so 3a cubed c to the power of 4. Question number 11, we can do a bit of Pythagoras to find the length AB. We've got BC and we've got AC, so the square root of AC squared minus BC squared, or 21 squared minus 15 squared, comes out as 6 lots of the square root of 6. I prefer to use exact answers if I can. For angle ACB, we can do SOHCAHTOA on the larger triangle. We have the opposite and the adjacent, you could use the hypotenuse if you want to. Any path through that is fine. So inverse tan of the opposite over the adjacent, 6 root 6 over 15 is 44.415, etc., etc. For DCB, we can do inverse tan of 9 over 15, which comes out as 30.96, and the difference between the two is 13.5 when I subtract one from the other. It is possible to do this question without calculating the length AB. You can find both of those angles from the lengths that are given to save you a little bit of time. Well done if you spotted that first time through. I certainly didn't. 13.5 degrees is the final answer though. Question number 12. An interior plus an exterior angle will come to 180 degrees because it forms a straight line. So 9x plus 27 plus 2x minus 23 is 180. Collect like terms. 11x plus 4 is 180. Subtract 4 from both sides. Divide both sides by 11. We get x equals to 16. Now you can find the interior angle if you want to here, and then use the formula for the interior angle. I've gone with finding the exterior angle. Plugging 16 into the exterior angle gives us an exterior angle of 9, and 360 divided by 9 is 40. So this is a 40-sided shape. Question 13a needs to add up to 1, so the probability of orange is going to be 3/5 from the bag, and then from the box we've got 3/8, 5/8, 3/8, 5/8. For B, the only way they could be the same colour is if you pick a yellow and a yellow, so I'm subtracting 2/5 times 3/8 from 1. There's a little shortcut, comes out as 17/20 for B. You can do that in a longer way if you prefer. For 14, expanding 7x times 3x plus 2 times 2x minus 5. I've expanded the double brackets first. 6x squared minus 11x minus 10, and then multiplied each part by 7x, giving us 42x cubed minus 77x squared, subtract 70x. For part B, I have decided to create two fractions with a common denominator of 14y. So 63 over 14y plus 10y over 14y is equal to 5. Add the numerators. The numerator becomes 63 plus 10y. All over 14y is equal to 5. Multiply both sides by 14y. And then bring the y's onto the right-hand side by subtracting 10y from both sides. Divide both sides by 60. We get 63 over 60. Simplify the fraction, or write it as a decimal, 1.05. So y is 1.05. Question number 15, finding the area of a sector of a circle. We've got theta 360ths of pi r squared, so 75 over 360 times by pi times 12 squared. Plug that in, you get 94.2 centimeters squared. Question 16, the interquartile range, where 15 people means the quartiles come at the 4th and the 12th. So we've got upper quartile 25, lower quartile of 4. The difference between those is 21, so the interquartile range is 21. Question 17, rationalizing the denominator. So we're going to multiply by a fraction equivalent to 1 with the conjugate pair to root 7 minus 3, so times by root 7 plus 3 over root 7 plus 3. Expand the numerators out, we get 14 plus 2 root 7 plus 6 root 7 plus 6 over the denominator 7 minus 9. Simplify that down, 20 plus 8 root 7 for the numerator and negative 2 for the denominator. Divide both parts by negative 2, we get negative 10, subtract 4 root 7. Now the question wants us to give our answer in the form a subtract root b. So I'm going to turn the 4 into a root 16 and then multiply it by the 7. So negative 10 subtract root 112 for my final answer. Question 18, making y the subject. First step is to square both sides. Then I'm going to multiply both sides by the denominator. Multiply both sides by 3y subtract t. And I'm going to expand out the left-hand side at the same time. So 3yp squared minus tp squared is equal to y plus w. Then I'm going to bring the y's onto the left and the non-y's onto the right. So subtract y from both sides, add tp squared to both sides, and factorize out the y. Y lots of 3p squared minus 1 is equal to tp squared plus w. Therefore, dividing by 3p squared minus 1, we get y equals tp squared plus w all over 3p squared minus 1. Anything equivalent to that is fine as well. Question 19 is the cosine rule. Helps if you know the formula for finding the angle from the cosine rule. So cos of theta equals b squared plus c squared minus a squared over 2bc. Plug the numbers straight in. I'll even do inverse cos or arc cos of that fraction. Plug it into your calculator. 71.8 degrees is the angle that we want. Remember, the 10 must be opposite the a. Question number 20, coordinate geometry question. So the gradient of line L is 4. You can read that off from the equation. M is perpendicular, so it's a negative reciprocal of 4, so that's a negative a quarter. So the equation of the line we're looking for, M, is y equals negative a quarter plus c. Plugging in the point 8, 1 into that, we get 1 equals negative 4 times 8 plus c. 1 equals negative 2 plus c. Add 2 to both sides, c equals 3. So the equation of the line is y equals negative a quarter x plus 3. Question 21, completing the square. So first thing I'm going to do is factorize out 5 from the first two parts of the quadratic. 5 lots of x squared minus 4x, and then add 23 at the end. Then I'm going to complete the square with the x squared minus 4x, so that will become x minus 2 squared minus 4 inside those brackets. Expand out the 5 lots of x minus 2 squared, subtract 20 plus 23, and lastly simplify 5 lots of x minus 2 squared, add 3. Question number 22. There are two possible ways in which we could be left with at least one pink in the box at the end of the taking out of the buttons. One is that there are no pinks that are picked, and the other is that there is one pink that is picked. The probability that there are no pinks picked, 13 15ths times 12 14ths times 11 13ths. And then there are 3 ways in which one pink could be picked. So that'd be 3 lots of 13 15ths times 12 14ths times 2 13ths. That comes out as 34 over 35 if you plug it into your calculator. Question number 23. So this is a fraction within a fraction question. We know that a is 2x plus 5 over 1 minus x. So I'm going to substitute the x in that for 5 minus 2y over 3y. So we'll get 2 lots of 5 minus 2y over 3y plus 5 in the numerator, and 1 subtract 5 minus 2y over 3y in the denominator. To simplify this, I'm going to multiply it by a fraction equivalent to 1. I've chosen 3y over 3y, as that will eliminate the over 3y parts of the numerator and the denominator. The numerator, so we've got 5 minus 2y times by the 2. The 3y's cancel, so 10 minus 4y. 5 times 3y is plus 15y. For the denominator, 1 times 3y is 3y, and then we're subtracting the 5 minus 2y after the 3y's have been cancelled in the denominator. Then simplifying numerator and the denominator, we'll get 10 plus 11y over 5 lots of y minus 5, and factorize the denominator. leaving us with 10 plus 11y over 5 lots of y minus 1, which is in the form the question wanted. Question 24. Okay, transformations of functions. First one, shift it 5 places to the left. Second one, shift it 7 places up. And the third one is a stretch scale factor of half parallel to the x-axis. So divide the x-coordinate by 2. So minus 1, 3, 4, 10, and 2, 3. 25 is a quadratic inequality. Factorizing the quadratic inequality, 2x minus 7, lots of x plus 4, that's greater than 0. We have a smiley face quadratic, and we're looking for the parts of that quadratic which are above the x-axis. Its roots are at negative 4 and 7 over 2, and so we want the bits to the left of negative 4 and to the right of 7 over 2. So x is less than negative 4, or x is greater than 7 over 2, or 3.5 if you prefer. Question 26. I'm going to draw in some lines to help us. So I'm going to call B to C x. Draw a line from B to E. If B to C is x, then A to D is 5x. And I'm going to draw a line from B to F. And perhaps you can visualize the triangle BFE. We know that the angle within that is 50 degrees from the question. Okay, so to find B to F, I'm going to do Pythagoras using the 10 and the 14. I'm looking at the base of the shape, the base rectangle, the diagonal of it. So square root of 10 squared plus 14 squared, which comes out as 17.2. Then we know F to E, which will be the same as A to D. F to E is going to be 5x, and so that will be equal to tan of 50 times by the adjacent that we just calculated, 17.2. It comes out as 20.5. You can work out x by dividing by 5 if you choose. You don't have to. And then the total volume is going to be the area of the cylinder created at the bottom plus the area of the triangle on top of it multiplied by the depth. So 10 times 14 times x, where x is a fifth of 20.5, plus a half times base times height, a half times 10 times 4x, lots of 14. Plug all that in, you get 1,720 centimeters cubed. Question 27 is the vectors question. In part B, it tells us that b to d to c is 1 to 3, but I'll ignore that for now. My path from B to C, I'm going to go from B to A, and then from A to O, and then from O to C. So B to A is going to be the negative version of A to B, so A subtract 4B. A to O is subtract 2A, and O to C is 5B minus 3A. Collect your like vectors. You get minus 4 lots of little a plus little b, and that's the vector B to C. Part B, that's the tricky one. So use a vector method to find the value of n, where O to P is n lots of O to D. So to do this, I'm going to construct the vector O to P in 2 different ways. The first way I'm going to construct O to P is by going from O to A and then from A to P. Well, O to A I know is 2 lots of little a, and A to P is going to be a scalar multiple of A to B. I know this because ABP is a straight line, so it's going to be k lots of 4b minus a. I've introduced the value k as the sort of the slider, the scalar multiple. If I expand that out, 2a plus 4k lots of b subtract ka, and factorize it to get 2 minus k lots of a plus 4k lots of b. That's my first way of finding O to P. The second way of creating the vector O to B is by calling it a scalar multiple of O to D. I'm going to call this scalar multiple n, because that's given to me in the question. So it's going to be n lots of O to D. So it's going to be n lots of my vector from O to D. I'm going to build the path by saying it's O to A plus A to B plus 1/4 of B to C. I know it's 1/4 of B to C because the ratio of B to D to C is 1 to 3. So B to D is 1/4 of B to C. Then plug in the path using the little vectors. We get n lots of 2a plus 4b subtract a plus 1/4 of minus 4a plus b. Simplifying as much of that as possible, we get n lots of 2a plus 4b subtract a plus 1/4 b. All of the a's cancel, and so we get n lots of 17/4 of b, or if you prefer, 17/4 n lots of b. So we now know that there's no little a component to this vector O to P, and therefore from the first construction of O to P, I know that 2 minus k must be 0, therefore k must be equal to 2. Then equating the coefficients of little b, we'll get 4k must be equal to 17/4 n. We know that k is 2, so 17/4 n must be equal to 8, times by 4, divide by 17, n must be 32/17, 32/17 as a top-heavy fraction. If you've done that as a decimal or a mixed number, that's absolutely fine. Question number 28. So we know it passes through the point 1/5, 13/5. I've turned it into fractions. I prefer working with fractions when it comes to coordinate geometry. I think it gives neater answers. Anyway, plugging in those coordinates, we'll get a 5th squared plus 13/5 squared is equal to d subtract 11 lots of a 5th. 1/25 is 1/25 plus 169/25 equals d subtract 55/25. Simplify that, bring it all onto the left hand side. We get that d must be equal to 9. Then we also know that it sits on the line L, so substituting the same coordinates into the equation for the line L, 13/5 equals 3 lots of 1/5 plus e. Subtract 3/5 from both sides, and we get that e is 10/5, or if you prefer, 2. So the equation of the curve is y equals 3x plus 2. I can substitute that into the top equation. So now instead of x squared plus y squared, it becomes x squared plus 3x plus 2 all squared equal to 9 subtract 11x. Expanding that out, x squared plus 9x squared plus 12x plus 4 is equal to 9 minus 11x. At this point, you should be realizing you've got a quadratic. Bring everything onto the left-hand side to make it equal to 0. You can use the quadratic equations formula at this point if you like. I factorized to make 5x minus 1 lots of 2x plus 5 being equal to 0. So x is equal to 1/5, or x is equal to minus 5/2. Now we were given the solution x equals 1/5 as part of the question. So that's x equals 1/5 is correct, but I'm going to ignore it because we're looking for the other point here. So x equals -5/2, plug that in, y equals 3 lots of -5/2 plus 2. 3 times -5/2 is -15/2 plus 2, and therefore y is -11/2. So our coordinates would be -5/2, -11/2, and we are done. Well done if you got that one. Right, bye.